polynomial long division is quite easy, I would say. In general, you just have to memorize how to divide on paper, how to do it manually, and then the division of polynomials is very similar to the division of numbers on paper when you do it on paper, right? So it's not too complicated, I would say, and it is well doable. I will show you how it works in a second with an example. Hi guys, now I want to talk about polynomial long division. What is polynomial long division? It's actually nothing special, I would say. It's just like regular division. And if you know regular division, then you already know how polynomial long division works. It's almost the same, so it's just a little bit different, and how different I will just show you. So what is a polynomial? A polynomial is something like x to the power of 2 plus 2x plus 7. This is a polynomial. Also a polynomial is 7x to the power of 3. This is also a polynomial. So all this kind of stuff, these are polynomials. And we can divide one polynomial by another polynomial. And it's actually nothing special, I would say. It's just like maybe 12 divided by 4, and there's a procedure how to do it. Okay, in this case it's maybe too easy, but it works like the regular division. So as an example, I use the following. So let's just say first polynomial on the left side is 3x to the power of 5 plus 25 x to the power of 4 minus x to the power of 3 minus 68 x to the power of 2 plus 35x plus 24. So this is our first polynomial on the left side, and then we say, okay, this divided by a second polynomial, which is x plus 8. And we want to know what the solution is. Actually, it's not very difficult, as I said. So as you may remember, maybe let's say 100 or 240 divided by 2, if you calculate it like by hand, then you start with the 2 and you say, okay, 2 and 2, and I subtract 2, and then I have 0, I get the 4, but I say this is 1 times 2 is 2, and so I get 0 if I subtract 2. I take the 4 down, then 4 divided by 2 is 2. So then I subtract the 4. Then I have 0 again. 0 takes 0 down. 0 divided by 2 is 0. So the solution is 120. And exactly by this way, that getting down the numbers and subtraction, you can divide like 240 by 2. In this case, it's very easy. You can do it also in your head. But in this case, you may not be able to do it in your head. So you need the same procedure as I just showed to do it with the polynomial. Maybe I just show it again, the procedure, how it works, maybe a little bit bigger to demonstrate. So you have, and this procedure you should remember, and then polynomial long division is very, very, very easy. Okay, so we have 240 again, as I just showed, divided by 2. This is what? If we calculate, I mean, we already know it, but if we want to use this procedure, then we start, okay, we start with 2. How to relate it? 2 divided by 2 is 1. So we know 1 times 2 is 2. Then we write the 2 below it and we say we subtract it, 2 and 2. It's like, we look at this like this, 2 and 2 is 0. And then we take the 4 down. So we have 0, 4. And 4 we can divide by 2. And this is 2. So we can say minus 4 0. You take the 0 down, 0, 0. How to get it? 0. So it works like this, taking down the numbers and using subtraction. And this procedure we use also for polynomial long division. So I just show how it works with our example. We start with 3 times x to the power of 5. So how to get this expression with the x? We get it when we use 3x to the power of 4. If we multiply 3x to the power of 4 with x, we receive 3x to the power of 5, right? And what the thing is, what we also receive, we have a plus 8. So if we multiply 3x to the power of 4 with 8, we receive the following. We receive 24x to the power of 4. And this is also why usually the powers are in a certain order. So we have the biggest power at the first place, then the second biggest, and so on. So it's a descending order in this case. And then we can subtract this polynomial from the long polynomial. And then we receive 25 minus 24, we receive x to the power of 4, right? So how to get x to the power of 4? We need x to the power of 3 times the x we already have. And this polynomial, x to the power of 3 times x is x to the power of 4. But first we need to add this one, because we work with 2 elements always. So x to the power of 3 times x is x to the power of 4. X to the power of 3 times 8 is positive 8 x to the power of 3. So we just have to subtract this, and then we receive minus 9x to the power of 3. We get, and maybe with errors if it helps you, and then we take 68 minus 68 down in the same line, minus 68 x to the power of 2. Then how to get to minus 9x to the power of 3? We get to this by minus 9x to the power of 2. Minus 9x to the power of 2 times x is minus 9x to the power of 3. Minus 9x to the power of 3 minus 9x to the power of 2 times 8 is what? It is 72x to the power of 2. So we have minus 72x to the power of 2. And we subtract this. Then there's a 0. And here's a plus then. And then we have 4x to the power of 2. How to get 4x to the power of 2? We need plus 4x. 4x times x is 4x to the power of 2. And we also have to take down the 35. And then we know 4 times 8 is what? 4 times 8 is 32. Plus 32, and not forget the x, 32x, we subtract again, then we receive 3x, and then take the 24 down, plus 24. How to get the 3x? We need plus 3 at the end. 3 times x is 3x, 3 times 8 is 24. So in this case, we see, okay, actually we have a complete division, so there's no remaining stuff. And the solution then is 3x to the power of 4 plus x to the power of 3 minus 9x to the power of 2 plus 4x plus 3. So this is the solution. This right-hand polynomial times x plus 8 equals this polynomial. So it's actually quite easy to calculate. But there's one thing I want to mention, because sometimes, especially in exams, usually when you practice, you always have something like this with no remaining stuff there. But in the exam, then suddenly you have remaining stuff and then no one knows what to do. But actually, you just need to think about if you have something left, for example, 5. There's 5. So remaining. So what to do with the 5? If there's no 0, but here is a 5, then what to do? Then you just add something to this polynomial. So we have our solution, plus 4x plus 3. And then you just add, at the end, you add another element, which is 5. So it's the remaining part divided by x plus 8. So divided by this one. So you don't really divide 5 by this, but you just write it down. You just add it at the end, okay? This is what you do if there's something remaining here. You take the remaining things, the remaining numbers or expression, and you build a fraction. So 5 divided by then this part. This is actually an important thing to know, because I know teachers and professors always try to give this problem to students in exams, but not during practicing before, not for homework. So this is a thing you should remember, and then actually it's not too difficult. You just should also pay attention to the multiplication part, so that you do this nice structure. Actually, if you really calculate with precaution, if you pay attention to what you calculate, then it's quite easy to do. But you should practice a little bit, and then it's no big problem. So this is how polynomial long division works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.